Hi friends, let us discuss Rabin Karp algorithm for string searching or pattern matching using hashing technique. The Rabin Karp algorithm is a string searching algorithm that uses hashing to find patterns in strings. This algorithm makes use of hash functions and the rolling hash technique to find patterns in strings. Let us see what is hashing. Hashing is a way to associate values using a hash function to map an input to an output. The purpose of hash is to take a large piece of data and be able to represent it in a smaller form. A rolling hash technique allows an algorithm to calculate a hash value without having to rehash the entire string. The hash function what we are going to use in this algorithm is h is equal to c1 then a to the power of k minus 1 plus c2 a to the power of k minus 2 and so on ck a to the power of 0. What is a means? It is a constant value which we select on our own interest. So we can choose any constant value as a. Then what is C1 and so on CK are the input characters. That means we assign some numeric value for the characters. For simplicity, we can assign A means 1, B means 2, C means 3 and so on. And what is K actually? K is the number of characters in the particular string. And also in hashing, all the operations are done modulo a prime number P to avoid dealing with the large numbers. That means whatever the result we get it by doing this calculation, we apply modulus a prime number P so that we can reduce the number from large value to smaller value. Let us apply this algorithm on a simple example with a 7 character string and the search string is 3 characters, that is DEC. This is the given string and we are going to search for the string with the 3 characters DEC. Our first task is to find the hash value of the search string. So here hash value of DEC is equal to what is the character value for D is actually we have to convert this D into numeric value. So as we already discussed, A means 1, B means 2, C means 3. So D means 4 and the constant what I have chosen is 7. And we apply the formula what we have discussed earlier, 4 into 7 square. So how this 2 comes? Because the length of the string is 3, so we start with the 0 1 2. So value for D is 4 and value for E is 5 and value for C is 3. You apply the formula 4 into 7 square plus 5 into 7 to the power of 1 plus 3 into 7 to the power of 0. So what you get? 234. So as we already discussed in the previous slide, so you divide by some prime number so that we reduce the size of the number. So the result is 3. So what is the hash value of such string is 3. Now you find the hash value of the first 3 characters ACD. So what is the value of A? 1. Okay, so 1 into 7 square plus what is the value of C? 3. 3 into 7 to the power of 1. What is the value of D? 4. 4 into 7 to the power of 0 and the result what we are getting 74. You find the modulo value of prime number 11. You get the hash value 8. So you compare with these two hash values. As these two hash values does not match, so we assume that the given search string does not appear in the first 3 characters. So we will compare only the characters when these two values matches. So now what is the next step? So we have completed for first 3 characters. Let us remember that we have to compare each character of search string in this main string only when the hash value matches with the hash value of search string. For example, here for the first three characters, the hash value is 8. It does not match with the hash value of search string. So we need not compare each character of search string with the first three characters. Now we have to calculate the hash value of next three characters CDE. Now what we can do, we can use the hash value of ACD to calculate the hash value of CDE according to rolling hash technique. Now use the hash value of ACD and subtract the hash value of A, because A has to be removed because we want to calculate for CDE. So from the ACD value, remove the value of A and add the hash value of E. So that means this value is 74 minus, what is the hash value of A? 49, and multiply by 7. Why we are doing it, I will explain it now. Next, add the hash value of E, that is 5 into 7 to the power of 0. So you are getting the result 180. Then you find the modulo 11, that is remainder after division by 11 you get 4. Again this 4 does not match with 3, so we need not compare each character. Now let me explain why we are multiplying by 7 with the subtracted value of the 74 minus 49. So this is what we call it as rolling hash technique. That means calculating the hash of CDE from the hash value of ACD. So what is the hash value of ACD? That we have calculated 74. So from that we are removing hash value of A, that is 49. But observe carefully, in the previous calculation C was in second place, so it was multiplied by 7 to the power of 1. D was in third place, it was multiplied by 7 to the power of 0. But when you come here, C comes to first place, that means it has to be multiplied by 7 to the power of 2. And D comes to second place, it has to be multiplied by 7 to the power of 1. That is why we are multiplying the subtracted value by 7 one more time. Plus calculate the hash value of E. So what is the number assigned to E? A is 1, B is 2, C is 3, D is 4, E is 5. Then 5 into 7 to the power of 0. Then calculate it. You are getting 180. Then you find the modulus value. The modulus after the final result is 4. This 4 does not match with this hash value of search string. So we need not compare each character one by one. So now what is the next step? The next task is calculate the hash value of next three characters DEC. So we apply the rolling hash technique. So we calculate hash value of DEC from the hash value of CDE. So now we have to remove the hash value of C. Again you add the hash value of C. Why it is so? Because in previous case C was in first place, but now C comes in third place. So you take the previous hash value 180 minus, what is the hash value of C in previous case? Here first place, no. So what is the number assigned to C? 3. 3 into 7 square, that is 3 into 49, 147. Then the subtracted value should be multiplied by 7. Why we are doing it? I already explained. Plus we are adding again the hash value of C. Again the number assigned to C is 3, but now it comes in first place. So that is 7 to the power of 0. So what is the value you are getting in? 234 modulus 11. We are getting the result 3. This value matches with the hash value of search string. So now I compare each character of the search string and these three characters. So I conclude that this DEC appears in this place. Now what we have to do? We have to take the next three characters. The next three characters ECB. So calculate the hash value of ECB from the hash value of DEC. That means remove the hash value of D and add the hash value of B. So what is the previous hash value? 234 minus, here the previous case D was in first place. That means what is the number assigned to D? 4 into 7 square, 49. That is 4 into 49, 196. And subtract these values and again multiply by 7 plus add the hash value of B. The hash value of B means B is assigned with the number 2 and multiply by 7 to the power of 0 and calculate the result. So you are getting 266. Find the modulo of 11 and the result is 2. This 2 does not match with the hash value of such a string. So we need not compare each character. Finally, we take the last three characters CBG, calculate the hash value of CBG from the hash value of previous hash, that is ECB. Now remove the hash value of E and add the hash value of G. So what is the previous hash value? 266. In previous case, the E was in first place. So what is the number for E? 5. So 5 into 7 square, that is 5 into 49, 245. So subtract these two and multiply by 7 plus we have to add the hash value of G. So G is assigned with number 7 and multiply by 7 into 7 to the power of 0. You are getting 154 and find the modulo of 11. The result is 0. So this does not match with the hash value of such a string. So we need not compare each character one by one. So now we conclude that DEC appears only in this place starting from third position.